This module introduces the concept of Secure Access Service Edge, SASE, and its importance in modern networking and cybersecurity architectures. Learners will understand the key components of SASE, its benefits, and its components. In the dynamic landscape of networking and cybersecurity, traditional approaches are evolving to meet the demands of modern digital environments. Secure Access Service Edge, SASE, represents a paradigm shift in networking architectures, offering a unified solution to address the challenges of today's distributed and cloud-centric infrastructure. Objectives: understand the evolution of networking architectures. Explore the journey from traditional networking architectures to modern solutions like SASE. Understand the limitations of legacy approaches and the need for more agile and scalable alternatives. Define Secure Access Service Edge, SASE, and its components. Define the concept of SASE and its core components. Gain insight into how SASE consolidates networking and security functions into a unified cloud-based service. Explore each of components of SASE. Dive into the individual components that comprise SASE architecture. Understand the role of SD-WAN, cloud security, zero trust principles, and other key elements in delivering comprehensive networking and security capabilities. In the following sections, we will delve deeper into each of these objectives, unraveling the intricacies of SASE and its significance in shaping the future of networking and cybersecurity. Traditional networking architectures typically involve a centralized approach, where all network traffic is routed through a central data center. This setup often relies on hardware-based infrastructure, such as routers and switches, to connect users to applications and data. In traditional setups, network security is often perimeter-based, relying heavily on firewalls and VPNs to protect the network perimeter. However, this approach becomes less effective in the face of increasingly sophisticated cyber threats, such as malware, ransomware, and phishing attacks. Traditional networking architectures face limitations in scalability, flexibility, and security. As organizations grow and expand geographically, traditional networks struggle to accommodate increasing bandwidth demands and support distributed workforce models. Additionally, traditional setups often lack the agility needed to adapt to changing business requirements and rapidly deploy new services or applications. SASE, pronounced SASE, is a transformative approach to networking and security that converges networking and security capabilities into a unified cloud-based service. It brings together wide area networking, WAN, and network security functions, traditionally delivered as separate services, into a single, integrated solution. The key components of SASE architecture. Software-defined wide area networking, SD-WAN. This is a method of managing and optimizing network traffic across multiple locations in an intelligent manner. Firewall as a Service, FWaaS, and NGFW inspects data more deeply than a typical firewall. For example, NGFWs can provide application awareness and control, intrusion prevention, and threat intelligence, allowing them to detect and block threats that may be buried in seemingly normal traffic. Cloud deployable NGFWs are referred to as cloud firewalls or Firewall as a Service, FWaaS. Zero trust principles. This security model operates under the assumption that there is no inherent trust granted to systems based on their physical or network location, i.e., local area networks versus the Internet. Cloud Access Security Broker, CASB. CASB acts as a security policy enforcement point, providing threat protection and ensuring consistent security policies across all network access points. Secure Web Gateway, SWG. SWG is a checkpoint that prevents unsecured traffic from entering an internal network and provides data protection. In the context of SASE, Secure Access Service Edge, SD-WAN serves as a foundational component. It optimizes network traffic flow, enhances application performance, and ensures secure connectivity across distributed locations. The architecture's virtual overlay decouples the physical network connections, which allows enterprises to retain existing WAN links while centralizing network control for real-time application traffic management. The architectural abstraction splits the network into control and forwarding planes. The control plane is located centrally, often at an organization's headquarters, to enhance network oversight and response. This way, administrators can write rules and policies to deploy across an entire network at once. Control in SD-WAN architecture separates from hardware to streamline network management, plus elevate service delivery and user experience. Operational guidelines from the central SD-WAN controller dictate the function of SD-WAN appliances, diminishing or removing the need for individual gateway or router management. A cloud firewall is a security product that, like a traditional firewall, filters out potentially malicious network traffic. Unlike traditional firewalls, cloud firewalls are hosted in the cloud. This cloud-delivered model for firewalls is also called firewall as a service. Cloud-based firewalls form a virtual barrier around cloud platforms, infrastructure, and applications, just as traditional firewalls form a barrier around an organization's internal network. Cloud firewalls can also protect on-premise infrastructure. Zero Trust Network Access, ZTNA, is the technology that makes it possible to implement a zero trust security model. Zero Trust is an IT security model that assumes threats are present both inside and outside a network. Consequently, Zero Trust requires strict verification for every user and every device before authorizing them to access internal resources. A Cloud Access Security Broker, or CASB, is a security solution that protects cloud-hosted services. CASB serve to protect corporate software as a service, SaaS, infrastructure as a service, IaaS, and platform as a service, PaaS, applications from cyber assaults and data leaks. CASB suppliers often provide their services as cloud-hosted software, however some do offer on-premise software or hardware appliances. Gartner, a renowned market analysis group, identifies 4 pillars of cloud access security brokers. Visibility: CASB solutions aid in detecting shadow IT systems and processes, particularly cloud services, that are not officially recorded and may pose unknown security threats. Data security: CASBs prohibit confidential data from exiting company-controlled networks, hence protecting its integrity. This capacity is particularly important given the development of AI tools into which employees may attempt to input sensitive material. Access control and data loss prevention, DLP, are key technologies in this domain. Threat protection: CASBs prevent data leaks while also blocking external threats and attacks. Anti-malware detection, sandboxing, packet inspection, URL filtering, and browser isolation can all assist protect against cyber threats. A CASB solution often includes a variety of security technologies in one integrated package. These technologies include shadow IT discovery, access control, and data loss prevention, DLP, to name a few. Compliance: because the cloud is so dispersed and beyond a company's control, it can be challenging for cloud-based businesses to meet stringent regulatory requirements such as SOC 2, HIPAA, and GDPR. Companies that fail to comply in particular industries and locations may face penalties and fines. By adopting strong security controls, CASBs assist firms that store data and execute business activities in the cloud in meeting regulatory requirements. A secure web gateway, SWG, is a cybersecurity solution that safeguards company data and enforces security regulations. SWGs connect firm personnel to the Internet. SWGs, like water filters, remove dangerous pollutants from water to make it safe to drink. They also filter risky content from web traffic to prevent cyber threats and data breaches. They also prevent unsafe or unauthorized user behavior. All SWG products include these technologies: URL filtering, anti-malware detection and blocking, application control.